Right, so this is a continuation of 6.1. We're going to do some formulas and stuff, but we're going to see if we can figure out these formulas on our own first. So this question number 1, we're going to use the 4 shapes A, B, C, and D down below to kind of help us out. So I will do the first one here. So number of sides for A is going to be 3 since it's a triangle. Measurement of one interior angle is going to be 60 degrees. The sum of the interior angles is going to be 180. And the measurement of one exterior angle, we can see that that's 120. And then the sum of the exterior angles. So if I count 120 plus 120 plus 120, we get 360 degrees. All right, go ahead, do the same things for parts B, C, and D. Go ahead and fill out that table, and when you're done with part B, part C, and part D, come on back to the video. Alright, so there is the table filled out. Now comes the tough part. See if you can see some patterns or how each thing is changing, and see if you can figure out what the next one would be. So I'm not looking for necessarily the number of sides 7. I'm looking for the number of sides being 8, 10, 12, 20, 30, 50, 100. Anything, right? So we're going to create an equation using n, where n will represent the number of sides. Once again, this is tough. See if you can figure it out. Pause the video and come back. All right, so once again, if you got 1 or 2 of these, you're doing well. This is pretty tough what I'm asking you to do, so if you're able to, great. If you got all 4 of them, that's pretty impressive. So the first one, which is the easiest one, is the sum of the exterior angles. The pattern here should be pretty easy, right? What is it? It's always going to be 360 degrees. So that one we don't even have to do any calculations for. We just know it's going to be 360 degrees. For this next one, the measurement of one exterior angle, you're going to see some relationship between these 3 parts of the number. The sum of the exterior angles, the measurement of one, and the number of sides. And I can see that if I multiply 3 times 120, I get 360. I can multiply 4 times 90 to get 360. 5 times 72 equals 360. So there's going to be a relationship regarding that. So the way I'm going to find this is I'm going to do 360 divided by n, which is the number of sides. And that's going to give me the measurement of one exterior angle. Right, so 360 divided by 3 is going to give me 120. 360 divided by 4 is going to give me 90. So that checks out. For some of interior angles, this one's a little bit tougher, but we should be able to see what it's growing by. And we can tell it's actually increasing by 180 each time. So this equation is going to be 180. But it's not going to be 180 times n, because notice it's going to be 180 with 3 sides, and 180 twice with 4 sides. So we're actually going to, what we want to do is do n minus 2. So therefore now we can just subtract 4 minus 2 is 2, and then 2 times 180 is 360. Same thing here, if we subtract 5 from 2, we get 3, and then 3 times 180 is 540. And this should actually make sense too, right? We know that a triangle sums up to 180 degrees. But if I suddenly have some sort of quadrilateral, that was actually really bad, so let me try that again. Do this, right? I can separate this into 2 triangles, where this is going to add up to 180 degrees, and so will that. So therefore we have 2 triangles in a 4-sided shape. Where if I have a 5-sided shape, we'll use this one down here, right? We now have 3 triangles that we can make inside a 5-sided shape. Likewise, we have 4 triangles we can make inside a 6-sided shape. So that's why we just add 1 extra 180 every time. All right, and the last one is the measurement of 1 interior angles, and it's actually not too bad if we're able to already know that and kind of look at this as well, right? So we're just going to take our 180 times n minus 2 and divide by n. All right, so once again, all of these formulas are on your formula sheet, so you don't have to memorize them, but that's where they come from. So let's look at question number 2 here. For each column in the last row of the table, formulate an algebraic expression for any n gone. Hint, use n in each expression. Okay, cool. We actually already did that. What I want to talk about was question number 3 here. So we looked at a regular polygon. Remember regular, meaning that we have all angles are congruent and all the sides are congruent. Do you think each of these expressions work for only regular polygons, or does it work with irregular ones as well? And the answer for this one is going to be that some of them are going to work with irregular ones as well. So if we look at this, our sum problems means we're adding up all the sides. So this is going to work for regular and irregular. Same thing with the sum over here. This is going to be good for regular and irregular because we're adding up the sides. But when we're looking at the 2 measurements of 1 interior angle, so this one and that one, this time it's only going to work for regular. Because in every shape, right, we're going to have different angles that are not, these are not all 90-degree angles, obviously. So we need to make sure that we don't use the measurement of 1 interior angle for any irregular shapes. All right, question 4, calculate the values of x and y. So we've been able to do triangle sum theorem. We've done that a lot. Well, we also have something called polygon sum theorem. And this is basically going to be the exact same thing, only we do have to figure out what they're going to sum to. So if I look at part A in question 4, if that was a triangle, right, we add up all the sides. So I'm still going to do that. So 68 plus 121 plus 103 plus 85 plus x. And now when it was a triangle, it was always equal to 180. But if I look back in my picture, what do the sum of the interior angles for a pentagon add up to? And my answer there is 540 degrees. So instead of saying this equal to 180, I'm going to set it up equal to 540. And from there, I can solve and get exactly what x is going to be. So when I add up 68 plus 121 plus 103 plus 85, I get 377 plus x equals 540. I can then subtract that from both sides and get x is equal to 163 degrees. So it works a lot the same. So whenever we have these problems, we're going to add up all the interior angles and set it equal to the 180 times n minus 2. So if I look at part D here, this one's a little bit, let's see what we got here. 1, 2, 3, 4, 5, 6, 7. So we have a 7-sided shape or a heptagon. And once again, that's not on my chart, but that's okay because I can add up all the sides. So I can say, add up all the angles, 2x. I'll start with this one and then just go in a clockwise direction. Plus 2x plus 10 plus 2x plus 2x minus 5 plus 2x plus 30 plus 135 plus 140 is going to equal 180 times n minus 2. Remember, n is always the number of sides. So since I have a 7-sided shape, I can say 180 times 7 minus 2 in order to find out what the sum of a heptagon of the interior angles is going to be. When I calculate that, and when I do 180 times 5, you get 900. So my equation will be 900, and then I can also combine like terms. I'm going to do this very carefully to make sure that I don't make a mistake. So I'm going to first add my x's. So 2 plus 2 is 4x, plus 2 is 6x, plus 2 is 8x, plus 2 is 10x. I'm going to get 10x, and then I'm going to count all of my numbers, just plain numbers. So I'll box these. 10 minus 5 is going to be 5, plus 30 is 35, plus 135 is 170, and plus 140 is going to be 310. And that equals the 900, and then I can solve. So we have 10x is equal to 590, and then divide by 10 so that x equals 59. And then I'm able to circle my answer there. So any of these problems, no matter how difficult, you just add up the interior angles and divide, instead of equal to the 180 times n minus 2. All right, some of these are a little bit different, like E and F. We start working on exterior angles. So I will do question E over here. And this one's just going to be almost exactly like interior angles, only we're going to do exterior angles, right? So 70 plus 60 plus 65 plus 40 plus y is going to be equal to 360, since exterior angles always add up to 360 no matter what. So then I can add up all those numbers and get 235 plus y is equal to 360, and solve for y and get that y equals 125. All right, and I'm going to leave it there with those problems. Feel free to do B, C, and F on your own for some extra practice. The notes are actually in Schoology with answers. All right, and we have this last problem to do. So number 5, here we're going to work on using the expressions of our formulas on the previous page to solve these. So the sum of the interior angles tells us exactly which formula we're going to be working with. That tells us we're going to be using the 180 times n minus 2. And it says of a dodecagon. So remember, n is always the number of sides. So we are going to say that 180 is equal to, I'll write it over here, 180 times 12 minus 2. And then we can solve and figure out what this is. So 180 times 10, which is going to be 1800. So my answer for this one is 1800 degrees. All right. B says the measurement of one interior angle in a 18-gon. So this one's going to be very, very similar. We just got to make sure we find, so it's an interior angle, and we want a measurement of one of the sides. So this is a regular 18-gon, so we're going to come up with the equation 180 times 18 minus 2, and then divided by 18, since that's our number of sides. All right, so we're going to be working a little bit backwards for part C here. So the name of a polygon with 4,140 degrees as the sum of their interior angles. So once again, that tells us exactly which formula we're going to be using. That's our 180 times n minus 2. But this time, we're trying to find the number of sides. It gives us the answer to this equation. So I can say is equal to 4,140. And now I can solve this and figure out what it's going to be. So, easiest way to do this is to divide by 180. Divide by 180. So therefore my 180s here are going to cancel out. And I'm left with n minus 2 is equal to 23. And then just to solve for n real quick, we're going to add 2 to both sides and get n is equal to 25. So the name of a polygon would be a 25-gon. And we can do the same thing for the other problems as well. So the name of a polygon with 1,440 as the sum of the interior angles. And just like B, we can only solve it with, we say, regular. So this has to be a regular one as well. I did forget that when I wrote the question. So there we go. And so I'll just write the equations real quick. You guys can solve them if you want. Once again, the answers are on the notes that are printed. So for part B, some of the interior angles, it's the exact same type of question. So we're going to say that 180 times n minus 2, once again, sum of interior angles is going to equal 1,440. You can solve for n there. And this one, the measurement of one exterior angle of a 36-gon, is going to be our 360 divided by n. And we are given that n is 36. So then I can just write 360 over 36. And that will give me the answer.